Hello class, we're going to be starting our new unit, which is going to be a continuation from our previous unit on graphing. And our first lesson is going to be on rates of change. We're looking specifically at speed today. You will see in your worksheet that there is an experiment. We are going to be skipping over the experiment, and I'm going to be going right into the second page, which has our example number 1, which you can see on the screen now. So the following graph shows how the distance a car travels changes over time during a trip. So as we can see on our graph, a couple things that I want to point out is that along our x-axis, again, which is our horizontal or along the bottom, we have our title, time in hours, and that lets us know what these numbers 1, 2, 3, 4 are all about. And then along our y-axis, we have the distance in kilometers. So these titles are very important. That was one thing from our last unit that I don't think I covered as well or made as specific, that how important they are. We also have our title at the top, which we should always have on our graphs. So we have distance traveled by a car. We have our spacing is all even along the sides and the bottom. So now we're going to go through it. So find the speed of the car using the graph. Speed is an example of rate of change, which is something that we studied in Unit 2. We want a unit rate, which is the distance traveled per 1 hour. So you guys remember that, per hour. So using the graph, what is the speed? As you can see here, it is 75 kilometers an hour. The way we find that is I go along 1 hour, and then I'm going to go up, and I see that it's at 75. If I go over another hour, we've increased another 75, and we go over one more, we've gone over another 75. So this line of best fit, as we can see, everything is nice and neat and straight and right along those points. There's nothing that's on the top or on the bottom. They all fit nicely, so we know that we can use that line to tell us that our speed is 75 kilometers per hour. So based on what we see, we can see that that's true. Sometimes it's not as easy though to see, to find the speed. The graph may not go up by ones along the horizontal axis. With any distance time graph, you can find speed by doing the following. So this will always work. So identify 2 points on the graph, and we are not using 0 ever as one of our points. So as we can see, the points we have here, we've got 3 and 225. So that 3 is our x-axis along there, and we see that it goes up to 225. So that's where we've got that number from. And 1 and 75. So we're going to use those 2 points. So again, we have our x and our y there. Let's see if I can figure something out for a second. It doesn't. All right, I was hoping I could put some things up there, but I can't, so we're just going to move on. So again, our 3, that's our x coordinate, and 225, that's our y coordinate. So x and then y. Now we can calculate the distance traveled by finding the rise, which is the vertical distance between two lines. So we can see here we have our rise. And so our distance traveled, so we have our bigger number, 225 minus 75. Always start with the bigger number and subtract the smaller one. So that's why on here we've started off with 3 and 225, and then we did 1 and 75. And not the other way around. It'll really help us out if we always choose the bigger point first and then the second point. So 225 minus 75 gives us 150 kilometers. So between those 2 times, we've traveled 150 kilometers. Next, we want to calculate the time by finding the run, which is the horizontal distance between 2 points. So again, this is our 3 hours and our 1 hour. And on our graph, so we can see we have our run, that's along the bottom. So we have 3 and 1, which gives us 2 hours. Now to find our average speed, what we need to do is we need to take the distance traveled, which is found up here, and we need to divide it by the time taken in this example, which is down here. So we have 150 kilometers and we have 2 hours. So we make a fraction, our rise over run. You'll always put the rise first, and then you're going to put the run on the bottom. So those are 2 key things that we want to key in on, especially when you are studying for your test later on. Rise over run. So 150 kilometers divided by 2 hours That's going to give us 75 kilometers per hour. So for every hour, we're going to travel 75 kilometers. So if you punch those numbers into your calculator, you should get 75 kilometers, or you will, unless you mixed up on your calculator. Try doing the same thing with 2 other points on the graph. So again, we can go back up and we can use our line of best fit. We see 4 goes all the way up to 300. 2 goes up to 150. So we're going to use those numbers there. So we have 4 and 300, 2 and 150. So we're going to do the same thing we did before, or calculate our distance traveled and calculate our time taken. So we have 300 minus 150. That gives us 150 left. And 4 hours minus the 2 hours gives us 2 hours. 150 divided by 2 will leave us with 75 kilometers per hour. Does it matter what 2 points you choose to find the speed? The answer is no. You can use any 2 lines that go on. So if this graph was extended, or if we wanted to even use these, we could use 4 and 1, or we can use 4 and 3. We can use any points along there, as long as we are taking the rise and then the run. We can use any of those to calculate the speed. So rise over run is called the rate of change, and it measures the steepness of the line. The rate of change of distance over time is the average speed. So the rate of change, distance over time, that's how we find our average speed. All right, let's look at our second example here. Natalie leaves downtown Ottawa and meets a friend at Dow's Lake, 6 kilometers away. She skates along the Rideau Canal. It takes her 5 minutes to skate 1 kilometer. Assume that she keeps skating at this rate. Create a table of values, that's down here, to show her distance from downtown for 5 minute intervals. Then graph the data. So as we said, she's traveling 1 kilometer every 5 minutes. So in our time, we're going to go up on even increments, up by 5s, 5, 10, 15, 20, and so on. And then every 5 minutes, we're just going to add 1 more kilometer. So obviously at the start point, she's at 0 kilometers. Then she travels 1 kilometer, 2 kilometers, 3 kilometers, and so forth. As you can see, we've got kilometers here, but then not down here. We don't need them because we have them written down in there. Okay, so first thing we need to do is we need to graph the data. So we need to find out which one is our independent and which one is our dependent. So our independent, which doesn't matter about the other one, is the time. Time will continue on regardless of how far we go. But the distance that we travel, that depends on our time. So that is our dependent variable. So our independent variable, time, goes along our x-axis down here. And our dependent variable is our distance from downtown, and that goes along our y-axis here. So as you can see, I've gone up by even increments. I've done every other line is 5. So I've skipped it over just to make sure that I'm using majority of my graph. If you remember from the video that we looked at the other week with our review, we want to make sure that we are using as much of the graph as possible. So we want to find out what's a good interval along the way. This one's pretty clear because we go up by 5s every time. So we're going to continue with that. Same with our distance traveled. See, we go up to 8 kilometers and we've got lots of room. So rather than trying to cram it all in, going 1, 2, 3, 4, we've spaced it out every other line equals 1 to make it a little bit nicer and neater for us. Also note with the labels that I've indicated the measurement we're using. So I wrote time and it's in minutes, and distance is in kilometers. We have our title is Skating the Rideau Distance versus Time. Okay, so that's what we're looking at, the distance versus time. So now we're just going to plot our data along the way, and we can see that everything lines up really nicely along there. And we can also indicate taking some points later on with our rise over run. So now that we've got it graphed, let's take a look. Find Natalie's speed in kilometers per minute and kilometers per hour. So rise over run, I would like you to always start by writing out rise over run. Please always write rise over run first. That way you always know which one needs to go where so that we don't confuse it. So our rise goes up. So that means we're going to be using kilometers. So we're using 6 and 4. So those are the 2 points we have indicated here. And that leaves us with 2. And then along our bottom from those 2 points, we start at 30. So our 6, so 6 and 30. And then we have 4 and 20. So 30 minus 20 for our 2 distances for our run leaves us with 10. So we would take 2, divide that by 10, and that's going to give us a decimal number of 0.2 kilometers per minute. So that means that she is skating at 2 kilometers per minute. So we want to find out, if we look in the question, per hour. So right now we have per minute. We need to bring that up to per hour. So we know that there are 60 minutes in an hour. So we would take both of those and we're going to multiply both of them by 60. Okay, we need to make sure we're doing both of them. So 1 times 60 gives us 60, and 0.2 times 60 gives us 12. So we needed to find that out. So 0.2 times 60 gives us 12. So that means that Natalie is skating at 12 kilometers per hour. How long does it take Natalie to reach Doe's Lake? It is 6 kilometers away. So we see, which is 6 kilometers away right there in our question. So we would use that information to find out how long does it take her to get there. Well, if she's traveling at 12 kilometers per hour, how long would it take her to do 6 kilometers? Nice, easy math for us. It will be half of this, so it will take her half of an hour, which is 30 minutes. So 6 kilometers away equals 30 minutes. So that is how we would calculate our rate of change in terms of speed. You guys will now go on to the practice questions. Remember, using those rise over run. Feel free to check out this video anytime you need to look back.